Hello everyone, this is Priyanka. Welcome to my channel Priyanka's IT School. Today I'm sharing next tutorial on software testing. In previous tutorial I have discussed black box testing and its test case design technique ECP, equivalence class partitioning. In this tutorial I'm going to discuss again test case design technique. I can say this is the second technique of black box testing, that is called boundary value analysis. So what is BVA and how we can simply solve the ISTQB questions? Let's see today. So basic agenda for today's session is boundary value analysis technique with some ISTQB questions. Very first, what is black box testing? Black box testing is a process where we can provide an input to the system and we can check output from the system without bothering into finer detail. So basically we are ignoring the coding part. Okay, so tester need to write just provide a data to the system and just test the output from the system. We are just ignoring this internal mechanism, or I will say the coding part. This is called black box testing technique. And for this technique, this consists total 6 different techniques which are called test case design testing techniques. So we have already seen there are total 6 techniques available: equivalence partitioning, boundary value analysis, then decision table, state transition testing, use case based testing, and error casing. In this session we are going to concentrate on the second technique, that is boundary value analysis. So guys, what is ECP? In the last session already we have discussed equivalence class partitioning. It is a process where we can divide the input domain, this input test data, okay, in the two partitions, valid partition and invalid partition. And for every partition we need to prepare at least one test case just to cover that entire requirement. So minimum number of test cases we require just to cover a maximum coverage of the client requirements. So in boundary value analysis, what is the concept? In boundary value analysis, guys, we need to test the input domain on boundaries. Okay, so basically here, like everything we are going to test, but on boundary value are most important values to be focused. Okay, so input domain we are going to test on boundaries. One is less than boundary and another is greater than boundary. This is called again the invalid boundary scenario. Then many system have tendency to fail on a boundaries. Okay, so checking boundary values, it's important to be focused, and that is the reason, guys, here we can simply consider this kind of the range. Whenever we have a data in the form of range, we can simply follow this kind of what I can say, the partition, or I will say the boundary value analysis technique. So yes, what is this? Let me explain. So here you can consider the mean boundary, that is called lower boundary, and max boundary, that is called upper boundary. Okay, so this is what the main technique to be followed. But let me explain. Boundary value is available in the two form. Okay, that can be a two value. Okay, that can be a two value, or that can be a three value boundary analysis. Now what is this two value, what is this three value boundary analysis? Let me explain. So guys, what happen if they ask you, let's say in ISTQB, if you have something like this question, okay, suppose input domain which is accepting 4 to 10 character. Okay, in that case, what you need to define, if you just consider equivalence class partitioning, then inside ECP we have very straightforward partition. The valid partition, I will say, yes, valid partition is 4 to 10 character, right, between the range. And whenever you go for invalid partition, so what are the invalid partition, guys? I will say less than 4 characters are not allowed, and greater than 10 characters also not allowed. So minimum 3 test cases, I will say minimum 3 test cases we need to focus in equivalence class partitioning. Now we need to understand what is boundary value and how to solve the same for the same example, boundary value analysis. When you talk about BVA, okay, inside a BVA you need to just concentrate on mean and max boundary first. That means if you have a range 4 to 10 characters, which is a valid range, then I will say 4 is nothing but on boundary value. This is called on boundary value. Now 10 is also valid boundary, and this is also called on boundary value. So many systems have tendency to fail on boundaries, so boundary values also we need to consider in our test case writing, right? And that is the reason for 4 character you need to prepare a separate test case, for entering 10 character, you need to prepare a separate test case. And likewise, if you consider this is a mean, and if you consider, let's say this is a mean and this is a max, then what we need to do, we need to just calculate mean minus 1. I will say here, okay, mean minus 1, and then we need to calculate max plus 1. So if you consider this is a range, so 4, 10 on boundaries and mean minus 1, that means one test case you need to write for a invalid boundary. Another test case you need to prepare, that is for 11. This is also referred as invalid boundaries. So I will say these inputs are called valid boundaries, right? These are what? Valid boundaries. But these are called invalid boundaries. Now, in this example, so how many test cases we require to prepare? If you just calculate boundary value analysis, I will say 4 test cases, okay? 4 test cases are required. But now again there is a question, like whenever you need to prepare for 2 values and 3 values, then how to prepare? So guys, it's very simple. 2 values, see the same scenario, 4 to 10. So if you consider this is a mean and if you consider this is a max, then mean minus 1, okay, mean minus 1 and max plus 1. So I will say 3 and 11. Okay, this is called whenever you are just concentrating on the lower and upper boundary with some max plus 1 or lower boundary plus 1, lower boundary minus 1 and upper boundary plus 1, then this is called 2 value boundary analysis. Sometimes the question is asked for 2 value plus 3 value, but this is called 2 value, or I will say 2 point. Okay, question might be asked for this type also, 2 point boundary value analysis. You need to identify whenever they ask you, okay, 3 value, then what is the concept of 3 value? Here we need to go for the same, like this is a mean boundary, okay, then you need to consider for every boundary, okay, the 3 value. That means what? I will say mean minus 1, that is called of course 3, and of course we need to go for mean plus 1 as well. Okay, so there is a 5th one also. If you consider 10, which is a max, then max minus 1, that is 9. Okay, 10 is again a valid boundary, and what we can do, max plus 1, that is 11. So for every boundary, in a simple way, for every boundary we are going to concentrate, okay, with some mean and max value, plus 1, minus 1. Okay, mean also minus 1, plus 1, in this way. This is called 3 value or 3 point boundary value analysis. So guys, in this way you are going to solve the ISTQB questions. So minimum number of test cases for 2 value, I will say 4 test cases, but for 3 value I will say total 6 test cases you need to prepare just to cover this requirement. Now, so boundary value, there is a simple concept, like you need to concentrate on a boundaries, and as per a boundaries you need to prepare a test cases. So these 2 techniques are very much important. But see what I will say now, if you just consider, if you just focus, so between the range, okay, all this between the values will be considered as a valid only, right? These values are also considered as a valid only. So I will say, like boundary value analysis is actual process, okay, which is extension of equivalence class partitioning, because whenever you are writing a test cases for boundary value analysis, automatically you are just covering the equivalence partitioning here, right? So I will say boundary value itself include ECP, and that is the reason boundary value is extension of equivalence class partitioning, right? Now let's go for some ISTQB questions quickly, right? How to solve ISTQB questions based on a scenario. So guys, be ready. Now the first question for you, okay, an input field takes the year of the birth between, this is the year 19 and I will say the 2004, then 2-point boundary value analysis for testing this field are, you need to identify, okay, 2-point boundary value analysis. Then guys, just think, if you have this kind of range, right, again the range is given like this one, right, this is a year. So if you have this is a range, then you need to just concentrate on 2-point boundary value analysis, right? That means this is a mean and this is a max. So max plus 1 and mean minus 1. So if I consider mean minus 1, definitely 1899 will be the answer, right? And max plus 1, I will say 2005, right? So if you go for the correct option, so which one is the correct option? I will say the C, right? Can you see 1899? Then this is your valid range, right? Valid range, valid range of year, and this is again invalid. So we can consider C is a correct option for this example. What is next? In system designed to work out the tax to be paid, okay, an employee has $4,000 of salary tax free. Then next $1,500 is tax at 10%, and next 28,000 is at tax at 22%, and any further amount is 40%. So guys, scenario can be anything, but yes, you need to remember that first you need to make a partition somewhere. Like sometimes, okay, you might get a complete partition, but sometimes if you don't have partition, that's your responsibility that you need to prepare a partition. But let me show you how you can prepare your partition. Okay, so first of all, like whenever you need to start, like how you can start in a simple manner, guys. Now this is the range, right? An employee has 4,000 of tax free salary tax free. Let's start with the 4,000 first. Okay, so this is a 4,000 first range we are getting. What is the second? Next 1,500 is tax at 10%. So you need to add, whenever there is a concept next, you need to add 4,000 plus 1,500. So I will say the next range will start, okay, from 4,001 to the added value. That means if you just calculate 4,000 plus 1,500, you will be getting 5,500. Simple. So 5,500. Then you need to go for the next range. What is the next range? The next 28,000 is tax at 22%. Okay, so let me add first 28,000 in the given data. Okay, so this will be, yes, 3,500, right? So the next range will be, okay, 5,501, and then 233,500. Okay, that is a third partition you will be getting. Okay, what is the next one? Any further amount is taxed at 40%. That means above this range. So can I write here? The range will start with this 501 and above. Okay, above any value. This is again tax at 40%. This is I will say tax at 10 and 22%, right? This is a free, right? 10%, and this is a 20%. Now, or 22%, whatever it is. Now what we need to do, we need to just identify which group of number will fall into the same equivalence class. Now this point is also important, guys. Whenever they ask you the same or valid or invalid, then based on this only you need to identify your options. Now let's see, the first option we have 4,800, 14,000 and 28,000. So is it these data are fall into the same equivalence class? Or because see, now we have how many partition? 1 2 3 4 partition. So you are going to search, okay, you need to search like inputs which belongs to the same partition. So if you just go for this first option, 4,800 and 14,000. So let me just tell you, okay, 4,800. Okay, let me take a different color this time. Option A, it is all about 4,800. Here it comes here, right? And the 14,000, so I will say it goes here. So this is not a correct option to be focused. Why? Because value should be focused. Value should be, fall inside the same class, same partition. If you go for the second option, 5200 and 500 and 5,500. So I will say 5200, that means here. Option B, okay, 5200, that means here. And then we can go for, yes, which is the next option? 500, okay, the same. 5500. And what is the next option? Okay, 28, that means it belongs to this class, right? 28,000. So again, we can't consider B as a correct option. What about C? 28,001, 32 and 35. So let me go for it. Yes, very straightforward. 28,001 and 32 is here, but 35 is here. Okay, it comes under above scenario. So we can't consider option number C as well. Let's talk about option number D this time. Let me show you. So 5,800, 28,000 and 32. Let me show you. 5,800, that means it belongs to the third class. 5,800, 28,000, it is also, comes under the same class, and 32,000 also belongs to the same class. So yes, what is the correct answer? Correct answer is option number D. Okay. So in this way, guys, you are going to solve your questions. Now, what is the next question? So I guess this is by referring the same scenario, you just need to identify to the nearest whole pound which of these is a valid boundary analysis test case. So now you got this particular, I will say the partition and the range. Now every range here, I will say this is what your valid boundary. Okay, so you need to judge the output that which is the valid boundary available in these particular, options. So very straightforward, guys. We don't have such a kind of valid boundaries. Only this option is correct. 33501. This is a valid boundary we have, right? To the nearest whole pound, this is a valid boundary we have, right? So this is the answer. In this question, option C is again answer for this particular question. Same scenario, you just need to do the partition and you just need to identify the boundary value analysis. Now let's go for the next question. Again, interesting one. Okay, you are testing a machine that score exam papers and assign a grades based on the score achieved. The grades are as follows. So again, guys, scenario can be anything. Okay, but you need to just prepare your classes and the partition so that you just identify the boundaries. Okay, so very straightforward boundaries are given here. Let me just go for boundary value analysis. In this case, what I'm going to do, I will simply capture the another scenario. Suppose this is my question. Okay, now let me show you directly on this particular page. So what we have a direct boundaries are given. So let me just call 1 to 49. If this is a score, then that user or that particular student will get F as output. Okay, fine. So 50 to 59, there is another range for D. 60 to 69, that is again for D. Then 70 to 79, that's for C. And 80 to 89, okay, that is B. And the students 90 and 100, those goes of course A. Now here, whatever the partition you found now, all this called valid boundary. Okay, so these all are called valid boundaries. So now what is the question? If you apply two value, again C, two value boundary value analysis, how many test cases will you need to achieve minimum test coverage? So what is the formula for two value? Already we have seen, if you have mean and if you have max, then mean -1 and max +1. This is what the two value boundary analysis you need to capture. Now consider this is a mean, okay, and we have this is a max range. So you need to consider one more test case which will be, yes, max +1, okay, that means 101, and mean -1. So mean -1, that is 0. So if you consider two value, then how many test cases you require? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So yes, correct option is D. Can you see? 14 test cases you require. But guys, this is very simple process. Only like you might confuse based on the scenario. Like if the scenario is very large, right? How to solve? Just solve slowly, step by step. Okay. So this is the way you can simply achieve. You can simply identify, the correct answer. Now let me show you the next question. So what is the next question for us? Okay, something like a big one again. Okay, a smart home app measures the average temperature in the house over the previous week and previous feedback. So what you need to do here, the feedback is given, okay, based on some temperature ranges, and these are ranges are given, okay, and it is asking again the same thing using two value or 2 point, this time 2 point BVA. Which of the following sets of test input provide the highest level of boundary coverage? Okay, now this time you need to capture the highest level boundary coverage. Let me show you how you guys can solve this question. So very first, let me capture the screenshot, and now let's understand. Very first, the process is very again simple. You need to just go for the ranges and you need to make your partition. See, up to 10, that means I will say like if I consider, okay, up to 10, so I will say like 10 and less than 10 are also valid. Clear? Then you can simply go for 11 to 15, next partition, 16 to 19, okay, another partition we have, then 20 to 22, okay, and above 22. So I will say 23 and again above, okay. All these are considered, okay. Whatever you are finding, these are valid boundaries, right? Now let's go for a options. If you just go for options, you need to just calculate now which, okay, which of the following set of test input provide the highest level of boundary coverage, okay. So now this time these are what boundary values. You need to just focus on these boundaries. Option A, 0, 0 Celsius, I will say here, okay, it comes here, about up to 10, no? So 0 Celsius comes here, 11, yes, then 20 will fall this class, yes, 22 here, and 23 here. So if you just consider valid boundary up to 10, so 10 is a valid boundary, but less than values we not consider, these are also valid, but this is not given here directly, right? So we can consider 0. If you just consider valid boundaries, so I will say valid is available 11, then 20, 22, and 23. So total 4 boundaries you found, okay, 4 boundaries. Just go for option number B, 9, 15, 19. So where is 9? See here, 9, then we have a 15, then we have 19, again we have 23 and 100, okay. So again, if you just focus, how many valid boundaries are here? 1, 2, and I will say 3, right? We are getting a count 3 boundaries. Now let's go for a next scenario. What are the ranges are given? Please check. 10, yes, this time we are considering option C. Let me write here, guys, option C, 10, okay. Then we have next range, that is 16, so it will fall in this class. Let me just write, okay, here option 16, right, C. Then we have a 19, okay, then we have a 22, okay, and then we have a 23, right? So how many valid boundaries are there? I guess all, right? 1, 2, 3, 4 and 5. This time 5 valid boundaries we found. Next, 14, 15. So 14 comes here, option D, okay. 14 comes here, 15 is also here, then 18 we have here, 19, okay, then in the same class, and then 21, okay. But here if you just focus on valid boundaries, so I guess 2 only, 2 values are valid boundaries, so the answer is 2B, right? So if you just notice, what is the question? The highest level boundary coverage. So highest level boundary coverage, of course, we are getting inside option C. 5 value are available as a valid boundaries, right? So highest level boundary coverage and option C is correct answer for this. So guys, in this way you are going to solve some ISTQB questions, right? That can be like any scenario if you want to focus, but you can quickly solve, okay, all these questions based on this ECP and boundary value analysis, just to practice, okay. And in case of any query, I'm just sharing my email ID in the description box. Just reach me by my email ID, okay. So that's all for the day, guys. Best of luck for your preparation, yeah. And that's all for this tutorial. Thank you everyone. Stay safe, stay tuned. Thank you.